Welcome to Code of India. It is the complete course Physics of class 11 that we learn in Learn and Play method. This course is applied basis so that you can visualize the thing about the physics. So it is a starter course that in your daily life, what you are getting, what you will get from this course. You will learn, explore about the physics to say about the world, how we live in around the world, what is going on due to physics. That physics has a lot of to say, and understand how some of our technological that were TV, radio and cell phone, how it works, the computer, how it works, and the microwave oven, how it works, and the GPS system, the mobile GPS global positioning system, how it works, electricity generation and use, how to generate electricity, and how you are using the diffusion system, the look at the physics of living, that food, exercise and radiation cancer. So that we are also learning more about physics in our daily life. That you understood that on learning of this physics, what is the requirement for the learning of physics, that course you do this. Lot of cool demonstration will provide, ask lot of questions to you, and let curiosity turn to country. So explore the physics of perception, that sound, light and temperature you have to understand, and steer the course to match your interest. So decide that physics is a way cool, not the worst course that even had in college. Not hard to learn. It's a very interesting course. Think over it. Let us. What you are going to learn, kinds of things you learn. How to look at circuit diagram without being clear. How to look at a broken radio and point out resistor, transistor, capacitor, diode, IC. These are the active and passive components of the printed circuit board. How your remote control works. How the music you hear is recorded and digitized and stored and replayed. Big question to you everyday life. How TV signal carry video information that you then see the screen on as an image on TV. How binary logic works and how this is implemented in computer as transistor block. Computer know only the binary logic, yes and no, true or false. And in computer that with the registers and everything, that ICs we are making reconstruct that the building block of IC is the transistor, the three terminal device. So how much energy you will use to keeping your house warm? How to keep your house warm or cold? That requires energy. Thus, to know all this, first of all you have to know the unit and dimension. Every physical element has certain unit and dimension. Quantity, the physical form a link between the physical world concept and the mathematical world quantitative. In physical world, what we are getting the concept, from where we derive the mathematics and calculate the quantity, value with respect to their dimension, length, Then we are length as meter, okay, feet, okay, weight, you know, the kilogram. So this inevitable involves measurement. That is the reason what we are getting from our surrounding, that the concept from the surrounding, you are getting the concept from the surrounding and calculating the thing quantitatively, the thing, the calculating or getting the value with some dimension, meter, feet, and that is called the measurement. You cannot avoid it. The measurement inevitably involve unit, length unit, breadth unit, volume unit, area unit, okay, weight unit. So the unit are that SI unit, MKS unit, that meter, kilogram, second, time is second, and other is CGS unit, centimeter, gram and second. And other is what? That distance in meter. 1 meter equal to 40 centimeter. Okay, 40 inches. The 2.4 centimeter equal to 1 inches. Okay. So mass is kilogram, kg, and 1 kg equal to 2.2 pound. You should have keep in mind. Convert the unit from one system to another system. Time is second, always both sides. So the second unit is what? We can multiply, divide the unit. The second unit is the combined variety of a form of complex unit, maybe which have their own name or symbol. So we are measuring velocity, that is distance per unit time, that is meter per second. Acceleration, velocity per unit time, that is meter per second square, or you can write meter per second, okay. And the force is mass into acceleration, m into a, that mass is kg, and acceleration is meter per second square, that is equal to Newton. In short, that work and energy, the force into displacement, this is force A and this is the displacement. Then what is the force? Force unit is what? Kg meter per second square, and displacement is meter, the meter square second square, that we can in shortcut say joule, that joule equal to Newton meter. Clear? Because here added 1 meter, m extra, so here is n, then m is added, it's become the n dash m, that's Newton meter, that is joule. So power is energy per unit time, that energy is work and per unit time. Then the S is second is Q, so it's become the watt, and watt equal to that joule per second, because here below side S have increased, so joule per second. This table is very useful and frequently used in your physics. So keep this table for your brain and your daily notebook, daily guidebook, your school guidebook. And the frequency is cycle per second, that is what 1 cycle per 1 second, that is a hertz. And the pressure is force per unit area, force acting per unit area. That force is what? Kg per unit area, okay, that is Newton per meter square, okay, that is a meter square, okay. So we got it, not at all problem. Then that all the thing that another thing that is the electrical unit. What is the electrical unit? What are the electrical unit and its dimension? How to measure its current, voltage, everything. That we deal with a lot of electrical phenomena that you have to learn about how to operate that equipment. And for that purpose, you have to know the unit, dimension, and measurement. So set of unit are mainly basically you have to keep in a thing that is charge. Charge is I. That is called coulomb. Okay, and that is shortcut say C. Okay, that what the electron per unit second. Okay, the current is charge per unit time. Okay, and I by time, the C by S, that is called ampere. In shortcut, that is called ampere. And voltage what? That is IR, product of the current and the resistance. That is voltage V. That in short comes say the volt. And resistance what? Divide of this volt per amp. That is called ohms. Symbol is this. Power is what? Volt into ampere. A volt is what? I into R. That is I square into R. Or if I divide the R, then this becomes V square by R. The volt ampere is the power. That is what? Joule per second. And electric field is what? Voltage per distance length. Per unit length, what is the voltage? That is V by M per meter. So you got it. So second is that every object, the wheel, the tire, the wheel of the vehicle have an inertia to start up. But when it started running fast, there is an inertia to stop. But when you apply brake, then wheel will say, no, I am running. Don't let me to stop. Then it will take, it's obstructing that inertia. Okay. So mass and inertia is the factor. The inertia depends upon the geometry of that moving object, which has certain mass. Okay, if mass is uniformly distributed, then the mass may be considered according to the direction of the movement of that component. Anyway, I am going very deep. Very simply, we can explain it that mass is how hard it is get something to move. You are lifting 10 kg, you are lifting 20 kg, you are lifting 30 kg, you are lifting, simply you can say more kg, more hard to lift. What is the size and shape of that weight? Let us say all are uniform. We will discuss that size and shape later on for advanced courses. So simply, the mass is acting like it's too hard to do something to move, and intimately related to the idea of inertia. Okay, that is the fact. Effectively, how many proton and neutron in the thing? Proton is positively charged, neutron is neutral, but it has mass. Similarly, distinct from the weight which relate to gravity. What is the reason lifting against the gravity, the weight? Requires some force. Okay? When dropping weight to resist it, require the force. So, the same mass weight, different amount of different planet. Because gravity of different planet is more or less as compared to gravity in the Earth, that we are taking the universal constant from Earth only. So inertia relates to the Newton's first law of motion. That one object in motion will remain in that state of motion unless acted on by a outside force. When you started the vehicle, wheels are in motion. To stop the vehicle, you have to outward force that is applied to brake. Stop the engine, no problem, you have to apply the brake. But without applying the brake, vehicle stops due to road friction, tire road friction. Okay, anyway. So outside external force is required to stop it. Wheel is in running motion. That this applies to being at rest simply when it is in moving. So it is the inertia of that moving wheel that he is not willing to stop. To stop it, we require some external force, just like brake and friction of the wheel with the road. Similarly, when vehicle is in standing condition, we want to start to run the vehicle, then a push-up is required because we don't want to move. Okay? That starter, motorcycle starter is required. Okay? So, motion relative to what? Then what Newton's second law says? You understood the Newton's first law. Newton's second law says, what about when there is an outside force? What? Outside not coming from within the body, an external agent is working on it. That force something that push or pull. Any object on the table, you are pulling your side or pushing out of your side. That external agent, your hand. Then we have a Newton. How much force is required to move that object whose mass is m? And in what speed, acceleration he will pulling or pushing, that is a. Then force is the multiplied of mass into acceleration m into a. Is it clear to you? Yes? Great. Now we have to talk about acceleration. That is rate of change of velocity. The rabbit hole gets deeper. But first let's give some example of force. Look. The example of force, open it. Open that door. Yeah, example of force is what? Gravity exerts downward force. Floor exerts upward force on the ball during the bounce. A car seat exerts a forward force. You are sitting on the car, a moving car, it exerts a forward force on your body to accept forward. And the seat you are sitting is now exerting a upward force on you. Can you feel it? Jumping the car. So you exert a sideways force on the crunch that you slide across the floor. The sideways force when the is sharp, the curving in a sharp angle. So string exerts a centrally directed centripetal force on the rod at the end of the string that you are pulling over your head. Expanding gas is your car cylinder exerts a force against the piston. There is a cylinder looking like glass. A piston putting inside the glass. When piston is inside, in between the head of the glass, that's a head, bottom, tail. and the piston, there is a gap. When there is air, when air is expand, then force is acting on the face of the piston. Before that, let us look at two things, very simple. What is centrifugal, what is centrifugal force? You might have that spring, okay, and there is a stone, and that other it is in your hand, okay, and rotating it is follow the path like a circle, okay, where string is the radius and your hand is the center. The two forces acting upon it. One force is tan of this, because your motion is clockwise direction, another force toward the center. That is called tangential centripetal force. Tangential force, tangent force you can say. We know the tan theta, okay? The centripetal, okay? And this force is normal force, centrifugal force, the force acting on the. So this is a very common thing, okay? To equalize, to balance this, you have to back draw. And to balance this, you have to back draw, okay, make an angle. It is 90 degrees, it is 90 degrees, okay. Anyway, so the syntax agent exerts direction forced on recipient. In which direction? Pull and push, that direction, such angle. So velocity and acceleration. Velocity is a speed and associated with the direction. Speed, suppose speed is what? A car start move from here to here, and stop here. Then total distance traveled by the car is, say, distance taken t, then okay, then d by t is the speed, okay. If you require to calculate the velocity, you don't take this part, it takes shortest part. That distance is small, or c. So d by t. So if I take it the shortest path from here to here, then take the here to here, then here to here, from here, then here to here. You can take the shortest path and calculate the velocity, adding all. Anyway, that. What you got? Let us take eraser. I think eraser is there. The velocity is speed and associated direction. Velocity gives the direction also. 10 meter per second toward the north, 50 meter per second straight upward. It's an example. Acceleration is any change in velocity. So either in speed or direction, acceleration measured as rate of change of velocity, not a rate of change of speed. Velocity is expressed in meter per second. Acceleration speed meter per second square, and space as a meter per second square. Okay. Anyway, the force acceleration connection is what that whenever there is a net force, there will be acceleration. That a ball thrown into air has a force of gravity operating on it. We are throwing on a ball. So gravity is acting on it. In what speed you have thrown from your hand, it is equating and balancing. The gravity force is increasing. Potential energy due to gravity is increasing with increasing height of the ball is increasing. When it will balance, then ball will stop and start to drop. Become zero, start to drop. So when you step on the gas, a forward force acts on the car, making the speed up. The force of gravity attracts the earth towards sun. Sun is bigger, mass is a factor. This is the effect changing the direction of earth velocity, trapping into the circle around the sun centripetal force. You understand centripetal? So a car slamming in the side of the another car already moving forward will exert a sideways force, changing the traveling car direction of motion. When the bat is hit a ball, large momentary force results in the large acceleration of the ball as well as contact is maintained. Anyway, all force great and small. But the relation, the force equal to mass into acceleration tell us more than the effect that the force and acceleration go together. And the relation is quantitative and depend upon the mass. For the same applied force, a small mass will have a greater acceleration. The mass is decision making. If mass is small, we have applied the same force as we had applied earlier, then what will happen? The acceleration we generate for the less mass will be more. Try to think over it. The larger mass will have the smaller acceleration because force is the dependent upon the mass and acceleration. If mass is less, the acceleration will be more. If mass is more, acceleration will be less. It's clear. So, force mass acceleration or force mass acceleration. You understand the font size of the mass? And you want the same acceleration as small mass required a small force. If any condition required that for the less mass to accelerate less, then you have to apply relation with the quantum of force. You have to decrease the force that we are going to apply. What we have applied earlier. You have to decrease 2%. So this then relates mass and inertia in intimate way. That is, the inertia is what? It is a property of the object that depend upon the mass, point of force acting on the mass, and shape of the mass. A rotary wheel, a square plate, the inertia property depend upon the shape and the point of acting force on the object and the mass. That is lead the inertia. Where the inertia comes? Why? You understand that point. So how hard it is to get an object moving? Let us look. Hold on a second that I've got a force acting on me right now, but I am not accelerating anywhere. Very perceptive. This is where the concept of net force come in. That is why force add, force cancel, total force. Acting direction of force is a big factor. Okay? You in the scene of the cricket. Okay? Making a 6 at the leg side, leg square is easier to make over boundary in a straight drive. So, you understand? Zero net force, how? Opposite. Sitting in your seat, gravity is pulling down on you, and but the seat reacting by pushing up on you, and the force cancel each other, and you are on the seat. If there is a disbalance, then you will adjust with your hand. So, pushing against the huge force of friction from the floor opposes this push, resulting in two net force and thus no acceleration. Clear? So Newton's third law. What is Newton's third law? That every action there is an equal and opposite reaction. For every force there is an equal and opposite force. What is this? Every action has a back reaction. That's third law. These are precisely equal and precisely opposite. Okay? And you cannot push without being pushed back just as hard. If you are driving out from the boat, you will have to push on the boat, then will jump front side and boat will push back side. We are walking ahead on pushing the floor, and friction is helping us to move ahead. So, in tug of war, each side experience the same force opposite direction. When you push on the brick wall, it pushes back on you. And that effect, that box is on the floor, the center of mass of that box is at this portion. At that point, the force acting downward at the gravity and force on the box floor due to floor pushing upward. If the upward force that floor is pushing upward is less than that of the downward force due to gravity, then floor will break. Any problem? So this is a very basic concept. We are pushing the wall. Box says where you stated that the forcing on the box by person. Force on that box is pushing the man with the help of leg feet on the floor. They are adjusting it. Okay? Understand? This is the thing who will be lower. You might have understood, I think. Wait for seated to side back. So, when we do the box and floor with the normal force from the floor cancelling the force, gravity, these will not strictly force pair. It is static, there is no changes, then both forces are cancelling. So, but these are the two cancelling force on the box that result in zero acceleration of the box. So, the real pair have to involve the earth, that is force pair earth box gravity box floor contact outside like this. Clear? This is the floor of the earth box thing. So don't all force be cancelled. Look at how does everything ever move, accelerate if the every force has the opposite pair. The important thing is that the net force on the object of interest. What is the net force? By equating the force according to the direction of the force, ball is going this side, in the same side I put it. Then the both force, net force become adding up both force. That is the main point of interest. What? Net force you have to calculate here. So the important thing that opposite pair, the important thing is that net force of the object of interest. Okay. Then gravity, what? In the gravity, one of the most apparent force is daily experiencing gravity. That gravity is mutual attraction of mass, but it always attraction, never repulsive. Gravitational force is always attraction toward ground. And all particles in the earth attract all particles in your body. So net effective force towards the center of the earth. And we are standing. Follow the law of force by Newton. That is force gravity equal to Gmm by R square. Where m is the mass of the earth, small m is the mass of your body that we consider while you are standing, and R is the radius separation, the center of the earth to your center of mass, between the object and the earth center. G is the, in M case it is 6.67, in SI it is 9.8. Okay. So note that force is a mass function. We can say the acceleration due to gravity. This is acceleration due to gravity. What acceleration we are getting? It is due to gravity. It's okay now. Any problem? So gravity on Earth's surface, if there is a surface, the global gravity Earth's surface is what? 3.9. That so it is in 9.8. Okay, per meter second square. R is the radius of the Earth, that is 6378. Okay, that bottom line, falling object acceleration is 9.8% on the surface of the Earth. Then what will happen? Downward velocity changes by about 10 meter per second with each passing second. Clear? Because 9.8 meter per second square is the acceleration, the downward movement, 1 meter square gone. The velocity what will get? 10 meter per second. 9.8 is about to 10. So this for the 1 kilogram of mass, that value of mass is in kg, because if you see the meter cube per second square. Okay, so that 1 kg into 10 meter per second square is 10 Newton of force. This is object weight mg, and support the book just normal force required to object from the accelerating. In other words, to make the net force on the book 0. It's now okay. You understand the force acting on the body, everything, very simple. Now the pressure density is the main thing. That the force acting per area is called pressure. M by A. So measure in Newton per meter square, where force is N and area is meter into meter, then weight make meter square. Any problem? And that is written in Pascal, that PA. The pressure of the atmosphere at sea level is about 105, that is 100,000 PA, about 14.6 pound per square inch PSI. Pound per square inch. That is called PSI. Okay? So 105 equal to PA equal to 14.6 PSI. So pound are also a unit of force like Newton, and density is a mass per unit. What is density? Mass per unit. That measure in kg per meter cube, always meter, then weight height, the meter cube, and mass unit mass is 1 kg. So kg per meter cube. And the water, if 1 liter water, then density 100 kg, 1000 kg per meter cube, same is 1 gram per centimeter cube. No problem. The serious unit. Air is about 1.3 gram per meter. Rock is around 3300 kg per meter. Gold is about 19,000 around kg per meter. These are the things, the density. Let us go. What is the purpose to know about the density? The energy, the capacity to do work. What is energy? The capacity to do work. If you don't have energy, you cannot do work. So the notion makes sense even in the colloquial text. What? Let us look. Hard to get work done when you are wiped out, low on energy. That work make you tired. You have used up energy. You have disposed of kilocalorie. You are losing your calories, so you feel tired. But we can make this definition of energy much more precise by specifying the exact what mean by work. That I told you earlier. So change in expansion or compression, the work more than just unpleasant task. But in physics, definition of work is the force into displacement. Where W is the work done and D is the F is the force applied and displacement took place, D. Then only the force that act in the direction of motion count towards work. Only the force that act in direction of the motion. The displacement took place. T took place. T increased. That factor is what? Force. and that causes the work done. So, unit of energy is what? Force is a mass, time and acceleration. Mass into acceleration is force. So mass has a unit of kilogram and the acceleration is meter per second square. Then what is the unit? Meter per second square is a kg per meter second square. That is 1 Newton. So work done. What will happen? The displacement d meter. Okay. The unit is what? Newton meter. Kg meter square. And it becomes the Newton meter. And that 1 Newton meter equal to joules. No problem. So 1 joule is 1 Newton of force acting through the 1 meter. Putting all values of 1. So imperial unit of force and distance are found at just 1.36. Okay? Unit of energy of foot pound, which equal to 1.36 joules. And energy has the same unit what as joules. Okay? So a note of arithmetic of units. You should carry unit in your calculation and then multiply and divide them as if they were a number. Think about the unit. In a problem, the value may be given in centimeter or kilogram. You have to change into kilogram. Value we might have given in feet of distance. You have to change in meter. So, example, the force on air drag is given by the drag force. That rho is the density of air, the air drag force, okay? And what is CD? Dimensionless drag coefficient. That we are dragging anything over a surface. At that surface, every surface has some properties. How much percentage it is decreasing? I told you the sine theta, cos theta. The sine theta is acting vertical, cos theta is acting horizontal. When any object is dragging with certain angle, say is dragging with the parallel to the surface. So vertical objection due to friction, roughness of the surface is zero. Only the horizontal section, the friction is working. So we are having friction to two components, the horizontal and the vertical. That is calculated by the mu. That one is dynamic and other is static. Okay. So that CD is that, and A is the cross section area of the body, meter square, and B is the velocity that we are calculating like this. The force is acting on that. How? Mass into acceleration. Clear? How is it? The kg meter cube into meter square, meter per second whole square. After adding, calculating the unit dimension, we are getting the new dimension. This is the dimension calculation, and kg meter square equal to Newton. Clear? So, what is kinetic energy? We are throwing the stone upward with a certain velocity. It is just after leaving the hand, the kinetic energy of that stone is maximum, and if the height increases, kinetic energy decreases, but potential energy is increases. due to height increase. So you have to understand this reversible behavior of kinetic energy and potential energy give the in adding both, that we will get the total resultant energy, that is a universal constant of energy. We have to maintain that. So what kinetic energy you understand little bit. The kinetic energy, the energy of motion, that half mv square. How we are getting half mv square? How? The note the v square dependence. This is why a car at 60 mph is 4 times more dangerous than a car at 30 mph. A hurricane force wind at 100 mph are most dangerous, substantive than 4 times of that 50 mph. A bullet shot from the gun is at least 100 times as destructive as thrown bullet, even if you can shoot with a tent as fast as the bullet. See there. That you have to understand. You will understand when we will calculate the projectile force. So what is the vertical component, what is the horizontal component, what is the mean value. Okay. Anyway, the typical example of kinetic energy you see, understand. A baseball, kinetic energy half mv square, no problem. A baseball mass is this. Then kg converted to gram, moving at a 30 meter per second, that 67 miles per hour. Has kinetic energy how much? This, no problem. If you convert unit, calculate the kinetic energy. So, this is kinetic energy half mv square. Okay, mass is kg converted to gram, and velocity is 5 meter per second, and kinetic energy half mv square, that is 0.07 joule. So it's not at all problem for us calculating. So now what is the potential energy I told you? Potential energy depends upon the height of the stone. mgh. Okay. So it takes work to lift a mass against the full force of gravity. Gravity is pulling down, I am pulling up. We are doing work against gravity of for that particular mass to move, and the force of gravity is mg, where m is the mass and g is the gravitational acceleration. And what is the work done? Say h height. Okay. The unit of the g is given here, that I told you earlier. The lifting at height h against the gravity force, the force into displacement is h. P is here h. Force into d equal to work done. That f into h. We have taken the stone upward till up to height h. The work done how much? Force into h. What is force here? Due to gravitation, it is mg, mass into acceleration. The total jet potential is mgh. No problem. So, rolling a ball off a hill, they are acting at two forces. The forces acting of normal of that surface, which is inclined along the base, horizontal, that angle, and the normal forces and the gravitational forces. Okay. The first example, energy exchange. Look here. When the boulder fall off cliff, it pick up speed and therefore the gain kinetic energy. Where does its energy come from? From the gravitational force of the end. And the higher the clip, the more kinetic energy the molder will have when reached to ground. More kinetic energy due to the potential energy. So mgh half mg square. Okay, graph is clear. The kinetic energy equal to potential energy should equate. Okay, we have the potential in mgh, no problem. You will be able to clear it. Kg meters per second and meter. Kg meter per second square and meter. No problem. So, in inclined plane, now we have to try to understand the work done F into D. In the sense, when the any object in inclined plane, okay, then at the center of mass of the object acting a downward force mg. So apply a large force over a small distance, or only apply a small force over a large distance, as W equal to F is same. Ramp with 10:1 ratio. For instance, required 1/10 of force to push a crate up. This arranging friction as compared to lifting with the straight arm. That inclination, what inclination will measure? That inclination, that gradient of this line, the sliding line, where that is the gradient, okay, that is tan theta, it is P by B, okay, and that is what? That is 1, consider, and this side is 10, then the ratio is what? 10 by 1. Now consider this is perpendicular, this is base, this is the angle. So this is the perpendicular and this is the base, 10:1. Under that condition, the required force is 1/10 of force to push the crate up. Pull it down. The surface, previously the surface, now H is high. Okay, that is H is say 1, of this length is 10, this length is 1. Now how much force required? That force is required 1/10. Previously it was force required to move that when this slab was in horizontal, that A force, now it is lifted up here, that is required F by 10 force. So total work done is raised crate is done due to mg. This H is the factor. We will let you know about the horizontal vertical component. Okay, mg by 10. Okay, so even through the kinetic energy, it's hard to derive the same useful work out of the because of motion are random. That energy of heat. Hot things have more energy. The molecules start to move fast. They are than the cold one. So the heat is really just kinetic energy on the microscopic scale and vibration and otherwise fast motion of the individual atom and molecule. So heat is frequently quantified by the calories. Previously it was quantified by the calories. Thus BTU, 1 calorie equal to this joule, 4.1 joule, okay, 4.2 you can calculate for that, okay, 4.2 joule, 1 calorie. Raise 1 gram of water per degree. 1 gram of water to increase the 1 degree centigrade temperature of water is required this sort of calorie, 4.2 joules calorie. You are walking, your dehydration took place, your body warming, then you have to calculate your work done calorie, exposure calculate. For that you have to consume same calorie of food. So 1 calorie raise 1 kilogram of water is 1 degree centigrade, and unit transfer, that B2 is this joules required to or Fahrenheit. Okay, that is not required Fahrenheit. That energy, heat and continue, that what is it saying, that the food calorie are with the big C or kilocalorie written, because this value are bigger, so make it the value small to kilocal. Okay, so since water has a density of 1 gram per cubic centimeter, this is standard density to replace with the other liquid density. We are comparing with the water. 1 cal heat 1 cc of water 1 degree centigrade is like 1 kilocal. Okay, here the cubic centimeter, not cubic meter. Okay, that is why it is 1 gram. That is 1 kg per meter cube. Clear? So 1 kilocal in 1 liter of water 1 degree to rise. Any problem? These are useful numbers to hang on to exam. To heat up 2 liter bottle of Coke from 5 degree centigrade refrigerator temperature to 20 degree centigrade room temperature required 30 calorie or 1.2 kilojoules. Heat capacity. What is my capacity to absorb the heat? That I told you earlier. Different metal have a different capacity for heat. Add same energy to different material and you will get the different temperature rise. Due to that capacity, the rise of temperature took place. It changes because different material have a different heat capacity and quantified as a heat capacity. That is water heat capacity what? 4180 joule per kg per degree centigrade. And most of the material are 1000 joule per kg per degree centigrade. That is including wool, air, metal. Okay. Example, to add a 10 degree centigrade to a room of the 3 meter of the size cubic, how much energy do we need? Air density is 1.3, you know. And we have a 27 meter cube. Okay, because 3 meter, one side, length, width, height, 27, 3 times. Okay, so meter cube. So the 35 kg of air, and we need the 1000 joule per kg per centimeter square. So we end up the needing 350,000 joule. Multiplying all. So, what is chemical energy? Electrostatic energy associated with the charge particle like electron. The static charge, the static portion acted on it. And is a stored charge in the chemical bond of the substance. The bond length rearranging this bond can release energy. When the bond breaks, it exposes of energy to the surroundings. When bond make, it's required energy to make a bond, to act a tie with 2 elements. So its required energy to be put in. Typical number are 100 to 200 kilojoule per mole, depending upon the element. So a mole is 6.2 molecule per particles. 1 mole having the certain particles fixed to all. Work out the typical numbers, several thousand joules per gram and a few calorie per gram. Remember, 1 cal equal to 1 kilocal equal to 4184 joule. This is a chemical energy example. Burning of wooden match releases about 1 BTU and 1055 joules, so that is greater than 3000 joule per nearly 1 kilocal per gram. So let us start power after a few moments. Take a rest. Okay.